So yeah, Jürg, I know him from studying at Rast, which is this place, formerly known as HSR, and he studied electronic engineering. And he works for Hamilton, not the Formula One Hamilton, but Hamilton Bonaduz. It's a hardware company specializing in lab automation. And yeah, they use Python to automate stuff in the lab. And I hand over to you, Jürg. Thank you.
Thank you very much. Yeah, welcome all to you all. Yeah, Rafi did a nice introduction of me. Just want to add I work at Hamilton since about 10, 11 years. Yeah, now it's 11. And to mostly, or like half-time Python, half-time I work on the embedded systems. And in the Python world, I do everything which has to do with our devices. So the topic today is lab automation with Python, building on solid ground. And let's jump straight in. Hamilton itself was founded a long time ago, and in 1950s in the States, and is now located also in Switzerland, in Bonaduz. And we have a wide palette of products. I work in the research and new technologies department in the Rapperswil, and we mostly work on the pipetting platforms. So how do they look? They are devices quite of some size, like 2 meters wide. And basically what you do with those devices is you place your samples on the work table and do some liquid handling and processing, for example, for blood tests, PCR tests. So many of you probably know, at least since the coronavirus, our company. About 8 years ago, we were tasked to create the next generation of the pipetting device. So here you can see the final product, and we worked on this part, which does the liquid handling. And the goal was to put everything which is needed to perform the actual liquid handling into a smaller case. Of course, make it faster, better, more precise. And this looks easy. Just take all those parts, put them together, and you're done. But actually, it all started out with a big mess. So we just basically combined all the parts we had. We knew that they are working and patched them together however it was possible. This was 8 years ago, and at this time we learned that the job is engineer because badass miracle worker isn't a job title. It's literally just try whatever works. If we look at the system we saw before, a more schematic way, it's not that hard. You have pressure sensors, you have scales, you have camera systems, you have different linear axis, motion controllers. Put everything together and control them from one system. The problem at that time was we did not have a software which was able to control all those systems. We had software to control the linear axis with our usual software. We had some vendor software for the pressure sensors and for the scales and for camera system, but how to fit all this together. Luckily, I knew a little bit of Python at that time, and we just started out. And luckily, many libraries were available on which we were able to build. So for many parts, we used just PySerial and hacked together some script. We were also lucky with the camera system. Someone reverse engineered it and released the Python driver for it. By the way, there is now official support by the vendor to access the camera system or there is an official Python SDK. Of course, we also used some packages or some parts of the standard library of Python, and many libraries like NumPy, Pandas, Matplotlib, OpenCV. So basically everything which is needed to perform the data processing. We ended up with a lot of code like this. So I only have this screenshot, but you can scroll up and scroll down. It looks all the same. It's just spaghetti code. At that time, we were forced to be fast because we had a deadline or with a clear goal to prove that the new technology will work. So in the end, if we look back, it was a big mess. Not only the hardware, but also software. It was mostly written as spaghetti code, just hacked together to get it somehow working. And changes on one end of the system often lead to problems on other ends, and the code was, how do I say, write once, never read again, you can't understand it again. But we were fast, and that was the main point which counted back then. And finally, we made it, we proved it that it is working, and the project kept going on. For the last few years, we've been working still on this product, and this is where we are today. We started to clean up all the code and build more usable drivers for internal use. So we put together everything which has to do with motion controllers in a separate package, which supports different communication protocols. So you can connect by TCP, by CAN, serial devices. Everything is covered and abstracted there. We have for the liquid handling head, the main part of our application, a dedicated package with all the functionality abstracted away. Then other device protocols, and on the left and right side, or if we start on the left side, liquid class support. Liquid handling is actually quite hard. You can't just use a syringe and pull some liquid, then dispense it at another place. You can do, but it will not be precise. So a lot of intelligence is abstracted away in its own package. And on the right side, you don't want to work with absolute position in your coordinate system. You want to work with logical positions. So we built the whole package just abstracting away all the details about the hardware. Using all these parts, we built one package which allows easier use, the Hamilton Vantage package. So instead of long spaghetti code, we ended up with something like this. For example, we have an analyzer interface where the firmware is sampling many internal signals at sampling rates up to 20 kilohertz. We transfer them via USB with the libUSB1 package. And thanks to Context Manager, we can start and stop the data acquisition, even if there happened something within the rest of the code. Finally, the data, once the acquisition is stopped, is put into a Pandas data frame for analysis. And we can even do live data processing with up to 1 kilohertz. So we have some demos lying around at our office where we do hardware in the loop with Python over USB. Sounds like horror for many of you. Well, maybe, but it's possible. as already said before, we wanted to abstract away complex things. So that's why you say, okay, I want to aspirate in a location named A1 and not at coordinate X, Y, Z, and there you put 3 numbers in. And you also don't want to care about the specifics, how to handle liquids. So that's why we built the liquid classes package. There we can also access the whole database of liquid classes, which was developed for the user software. In the meantime, it's still very important to get access to a lower level, especially for us in the research department. Sometimes new features are introduced in the firmware, but we don't have the time to integrate it in the Python driver, so we just resort to the low-level functionality directly. And you can mix and match those 2 styles. So today we have clean libraries for our devices where complexity is abstracted away. And even non-programmers can at least understand or reason about what is happening in a script. This is a very important part for us because we have mechanical engineers which support all the long-term testing. And it's important that they, without a lot of programming experience, can understand what the script is doing. And with GitHub Copilot and similar tools, probably it will also be possible for them to write their own script soon. So that's the state today. But if we look to the future, we now have a very good base in-house to work with. And if we take a look what are others doing, look at some recent paper, the use of AI in robotic systems, autonomous chemical research with large language models, or a mobile robot chemist. All papers recently released or published, they all suffer from one big problem. All vendors of laboratory equipment provide their own vendor-specific software, which is usually closed. So each lab decides which vendor they buy in, and they stick with this. It's hard or impossible to exchange protocols or some automation tasks between different vendors. And also, what's really tricky, the vendor software is closed and hard to extend. This is a big problem if you want to integrate the latest AI technology, because you can't do it unless the vendor will do it for you. So this came up last year. PyLab Robot, an open source hardware agnostic interface for liquid handling robots and accessories. What is their idea? They want to build, or are building, a central library which can be used with different vendors. As it's all written in Python, you can combine it with AI assistants, third-party tools. You can use whatever package you find on PyPy or use your own package. And you can write protocols, how to process something on a pipetting robot in an agnostic way. So you can share it with other people, which is really important in the research. So one lab makes new discoveries and another lab wants to reproduce those results. So they are also having one big issue. On this side, The AI assistants, interactive views, third-party tools, no problem. But how to handle this side? At the moment, everything inside this package is reverse engineered. So they analyzed all the log files produced by our software and just figured out what is going on and wrote the driver. So this takes a lot of time, effort, and it's not, it's buggy sometimes, or at least not all features are covered. So how can we as vendor help here? Basically, if Hamilton would build an open interface to the devices and provide a library where we can implement all the features and therefore provide a stable package, we would simplify the work of the team behind PyLab. And after many years of working on solid ground with well-established packages like PySerial, PythonCan, libUSB, we really think it's time that we also provide a solid ground for others to build on top. Thank you.
All right, thanks a lot for your insight into lab machines. Are there questions from the audience? I don't see any hands yet. I have a question. Is it still on the roadmap that you open source your own drivers, or is there like a time horizon that you estimate?
It's not on the roadmap, but we are looking. We are try to follow these projects which are open source, especially PyLab, because it's the most advanced and there's a lot of stuff going on there. So it's an active development and it's already used by some companies. So it's mostly used in research because the regulations about how you work are not that strict. And yeah, we are tracking their efforts and also had some discussions with them on how to go on.
Okay. There's an open hand up there.
Thank you very much for the presentation. I'm wondering what made you change, or let's say to open, to democratize? Because in general, I understand that the medical industry is closed because there are regulations for good reasons, right? So why your company is trying to pioneer this approach?
It's not that we will open completely. So there are there are two main parts in how our devices are used. So on the one side, you have the analytical field, which is strongly regulated. And there, it's hard to open up. So those customers will stay with our vendor-specific software. But on the other side, if we look at what's going on, they do reverse engineering. So why not help? So it's just it happens anyway that you will be able to control those devices with open source software. So we don't see a reason to hold against this trend.
Are there further questions?
And maybe just to add, one more thing is, of course, if we provide the driver, they provide a good abstraction layer of this. We can also later profit of this when we, again, can use it in-house. So, yeah.
Hi, I was at a talk from TECAN about 2 years ago where they explained why they might use the Zila standard to at least have a public interface to their closed source things. I know that you looked into Zila a few years ago as well, because I'm working on the project. But can you say anything about that? Was that a dead end for you, or?
No, not yet. Not
Okay.
yet.
Thank you.
Are there further questions? Otherwise, I would another one. And I would have a question about, like, did you hear about there's an open lab system that I heard of that's kind of like building a pipette or liquid handling machine, like Octa something?
Yeah, of course. Funny enough, HiLab Robot is also working with OpenTrons, but somehow it not. This is from their paper, and it's not mentioned here on this graphic. But of course, there's OpenTrons, which was, I think, started as a startup, and they had or they have open source drivers for their devices, and they also already have AI assistants. So if you want to do a PCR test on a device, you just talk with the robot, and you will get your program to run the PCR test. Yeah.
All right. So if there aren't any more questions, let's can continue. So thanks a lot for your talk.